Dear students, in today's lecture we will discuss about first law of thermodynamics. This first law of thermodynamics is also called as law of conservation of energy. This law states that energy can neither be created nor destroyed, although its one form can be changed into another form, or the total energy of the system and its surrounding remains constant. These both are the statements of first law of thermodynamics. Now, according to the statement, the energy lost by one system will be equal to energy gained by the other system or its surrounding. Energy may be transferred into the system or energy may be transferred out of the system in the form of heat and work. Let's consider a system enclosed in a cylinder and it is fitted with a frictionless and weightless piston. Then the initial energy of the system will be denoted by E1, and suppose heat Q is added to the system, then according to first law of thermodynamics, it will increase the internal energy of the system and it will do some work by pushing the piston upward against the external pressure. Now a new form of energy will be obtained, that is E2. Now the change in energy, that is denoted by delta E, and delta E is equal to E2 minus E1. Mathematically, the first law of thermodynamics can be defined as Q is equal to delta E plus W, or upon rearranging it can also be written as delta E is equal to Q minus W. These both, equation number 1 and equation number 2, these are the forms of first law of thermodynamics, in which delta E is change in energy, Q is heat evolved or heat absorbed, and W is the work done. If there is a very minute change, a very small change is there in energy, work and heat, then delta E, that can be replaced by dE, Q will be replaced by dQ, and work done will be replaced by dW. Now the work done, it may be positive or it may be negative. It depends upon that the system is doing work on the surrounding or the surrounding is doing work on the system. Now there are some special conditions, and these special conditions can change the mathematical form of first law of thermodynamics, in which the first one is, if there is no work done, then W in the first law of thermodynamics will be equal to 0. Then the first law of thermodynamics, that is Q is equal to delta E plus W, now it will become as Q is equal to delta E because W is equal to 0. Now this equation states that the heat given to the system will increase the internal energy of the system and no work will be done. Second condition is, if no heat transfer take place, then in the first law of thermodynamics, the Q will be equal to 0. The heat supplied will be equal to 0. Then delta E will be equal to W. And the third case is, if heat is added to the system and some work is done, then delta E will be equal to Q plus W. That is, the heat increase in the heat of the system along with work done. So all these three conditions, these are different forms of first law of thermodynamics.